Lumia and diffraction lens is an amazing piece of accessory we offer in our shop. Have you ever wondered what's the difference between diffraction and Lumia lens? I will show you in this episode. Check this out. Unlike a magnifying lens, diffraction lens is completely flat. If you hold it up to the naked eye, it just looks like a clear plate window. So how does a flat piece of glass manipulate a laser beam? It all comes down to microscopic engineering. These lenses are usually made from high-quality optical glass, fused silica, or specialized polymers. To create them, manufacturers use a process called photolithography, which is actually the exact same technology used to print computer microchips. Using this highly precise technique, they etch millions of microscopic grooves, ridges and stabs directly into the surface of the glass. These etched patterns are super tiny. In fact, their depth and spacing are calculated down to the exact wavelength of the laser light they are designed to manipulate. So, here is what happens when you turn the laser on. A standard curved lens uses refraction to simply bend the light, but diffraction lens uses diffraction. When a highly concentrated laser beam hits the micro-etched surface, those tiny ridges physically chop the light wave up. As the light phases through the grooves, the waves are forced to overlap, bump into each other, and interfere in highly specific ways. Because the pattern on the glass is based on pure mathematics, engineers can calculate exactly how those light waves will behave. They can force that single solid beam to split apart and project almost any shape you can imagine onto a wall, whether that's a sharp grid, dotted circles, or complex crosshairs. While diffractive lenses are all about mathematical perfection and sharp geometric lines, a Lumia lens is the exact opposite. It thrives on chaos. If you look at one up close, it doesn't look like a high-tech precision optical component at all. Instead, it looks like a piece of heavily textured shower glass or a window completely covered in thick, flowing rain. Because the goal is to create random organic patterns, the manufacturing process is much more artistic than scientific. These lenses are typically made from textured optical glass or specialized acrylic. Often, they are created using a glass working process called kiln slumping. The glass is heated in a kiln just to the point where it begins to melt, warp and sag, creating beautiful irregular ripples, bumps and wave across its surface. Because of this melting process, no two Lumia lenses are ever perfectly alike. So, how does this bumpy glass turn a laser into a liquid sky? To make it work, the laser beams are going through the textured glass that is cut into a disc and attached in front of the aperture. When you fire a tightly focused laser beam through it, the light relies on refraction, bending as it passes through the material. But because the galvo scanners are slowly moving, the laser is constantly passing through a different thickness, slopes and curves. This completely shatters the rigid beam, continuously stretching, smearing and bending the light into overlapping waves. When you mix red, green and blue lasers through this rotating texture, the color blend and separate dynamically on the wall. So in general, the whole optics kit you can buy on our website includes 3 Lumia lenses, 3 diffraction lenses, and 1 focal lens, which is also called a blurry lens. Also, a while ago we just released a new separate diffraction lens kit, which will also be present here in this video. It includes a burst lens, line lens, and radical lens. Let's see how they work. What do you think about this kind of special effects for your laser projector? Let us know in the comments. See you later in another episode.